In Unit 2, opener number 6, we have 3 different equations to solve. We're going to see that each one ends up having completely different types of solutions. When we take a look at the first equation, let's solve it for x using inverse operations. The first thing that I see is that the quantity 2x plus 6 is being divided by 3. So I'm going to do the inverse operation of division and multiply both sides by 3. Remember that whatever you do to one side of an equation, you have to do to the other side of the equation as well to keep your equation balanced. On the right-hand side, my 3's cancel out, and I'm left with 2x plus 6. On the left-hand side, I have 3 times 12, which is 36. Now I have a pretty straightforward two-step equation to solve. I see that I'm adding 6 to my x's, so I'm going to do the inverse operation of addition and subtract 6 from both sides. On the left-hand side, I have 30 equals, on the right-hand side of the equal sign, I'm left with 2x. And finally, to get x by itself, the x is attached to the 2 by multiplication, so we'll do the inverse operation of multiplication and divide both sides by 2. 2 divided by 2 is just 1x, and then 30 divided by 2 is 15. So we see that we have a solution of x equals 15. What that means is if I want to go back and check, there's only one x value that I can substitute in here on the right-hand side, multiply it by 2, add 6, and divide that quantity by 3, and get 12. Let's just check real quick and make sure that it works. 2 times 15 is 30, plus 6 is 36. 36 divided by 3 is in fact 12. It's always a good idea to go back and just take that extra quick step of checking your solution. In part B, I'm going to start the exact same way that I did in part A. I see that I'm dividing by 2, so I'm going to take both sides of my equation and multiply by 2. On the right-hand side, the 2's cancel out, and I'm left with 2x plus 6. And on the left-hand side, I have 2 times the quantity x plus 3. I'm going to put some parentheses in there to make sure that I remember to distribute my 2 to both terms. So when I do that, I get 2x plus 6 equals, on the right-hand side, I have 2x plus 6. And hopefully what you see here is that something interesting is going to happen because I have exactly the same expression on the left-hand side of the equal sign as I do on the right side of the equal sign. So if I go ahead and try to combine all of my x's to the same side of the equal sign, I'll go over here. I see a positive 2x, so I'm going to take away 2x from both sides of the equation. But what happens next is unusual. I have 2x minus 2x, which leaves me with no x's. So on the left-hand side, I just have 6 equals, and then I have that same exact thing on the right-hand side. 2x minus 2x means I have no x's. And so what I'm left with is 6 equals 6. Well, that's true. 6 does equal 6. Whenever this happens and your variables cancel out and you're left with something that's true, that means that x can actually be any real number. So what that means is for part A, there was only one possible value of x that I could substitute in and get the correct solution to my equation. For part B, any number that I could possibly try to substitute in for x will give me something true. So for example, if I try substituting in the number 1, on the right-hand side I get 2 times 1, which is 2, plus 6 is 8, and 8 divided by 2 is 4. When I substitute 1 in on the left-hand side, I get 1 plus 3, which is also 4. 4 equals 4 is true. That same thing would happen no matter what number I try to substitute in. I could plug in a fraction, a decimal, a negative number, a huge number, and I would end up with an equation that's true. So x could be any real number. Finally, for part C, I see that I have a proportion. One way to solve a proportion is that you could cross-multiply. It's called the means extremes product theorem. There are some people that are really opposed to this idea of cross-multiplication. I think it might be just because sometimes people try to cross-multiply any fractions even when it's not a proportion. So what I'll do just to make sure that I'm pleasing everybody is instead of solving by cross-multiplying, I'm going to solve this equation the same exact way that we did the others. So first step I'm going to do is multiply both sides by 5. So what that means is on the left hand, on the right hand side of my equation, my 5's cancel out and leave me with x plus 6. And on the left hand side of the equation, I have 5 times the quantity 2x plus 6 over 10. Now I'm going to go through and do a very similar step. I'm going to get rid of that 10 that's in the denominator. The inverse operation of division is multiplication. So I'm going to multiply both sides by 10. So that means that those 10's will cancel out. And on the left I have 5 times the quantity 2x plus 6. And on the right hand side I'm going to put parentheses in there. I have 10 times the quantity x plus 6. Next step I'm going to do is apply the distributive property. So 5 times 2x is 10x, plus 5 times 6 is 30, equals 10 times x, which is 10x, plus 10 times 6, which is 60. Something similar to part B is going to happen, but this time it's going to be a little bit different. I'm going to take away 10x from both sides. And same thing happens again where I have 10x minus 10x on the left and 10x minus 10x on the right. So my variables drop out again, and I'm left with just an equation with numbers in it. 30 equals 60. What's different about this one than part B was in part B, the equation that I was left with was true. I had 6 equals 6, and that's true. 6 does equal 6. This time I'm left with 30 equals 60. Well, 30 is never equal to 60. That's false. So this time what we have is x equals no solution. There is not one number in the whole entire world that I can possibly substitute in for all those x's in this equation and end up with something true. So just to sum up, there's 3 completely different types of equations. In part A, we got one solution for x. There's only one possible value that I could substitute in for x and get an equation that's true. In part B, my variables dropped out, and I was left with an equation that was true always for any real number of x. And so that means any possible number that you could pick to substitute in for x, you'll always end up with a true equation. And finally, for part C, my variables dropped out again, but I was left with something that was false, and that meant that there was not one possible value that you could substitute in for x and end up with a true equation.